Hey, welcome to an Edge Factor virtual workplace experience. Today, Ryan talks to us about how Wolters Group fabricates steel for the construction industry. We will be looking at the following chapters. Chapter 1, an overview of Wolters Group. Chapter 2,
education and career pathways at Wolters Group.
Chapter 3, tools and technology found at Wolters Group. And finally, Chapter 4, the steel fabrication process. Let's get started.
Hi, I'm Ryan Koppler, a plant manager here at Wolters Inc. in Hamilton, Ontario. Wolters Inc. was founded in 1956 by my great-grandfather, Walter Koppler Sr. Wolters Inc. is a structural steel fabricator. We build anything that a magnet will stick to. So we've done hospitals, bridges, high-rises, arenas, stadiums, pedestrian walkways, among many other things. We have a total of 4 fabrication facilities and our main office where all the engineers, project managers currently work out of. So we want to make sure when we're building buildings that not only do we make our customers happy, but we make our suppliers happy and our employees happy. If everybody is happy, then everybody is winning. If somebody is not experiencing happiness with us, we don't find that a very good business practice. So we all want to be happy. We all have lives outside of Wolters as well, and we want to keep everybody here as happy as they can and treat everybody like family. What's really interesting about what Wolters does is we get to build the skeletons of many buildings around North America, especially in Toronto, New York City, Calgary. So you get to see a lot of our buildings and bridges up close and personal. So it's very interesting when you're driving through these cities and you're able to say, we built that, we were a part of that, and we helped on this project. So being able to see something of significance like that. So the types of services Wolters offers is right from design assist to erecting the steel on site. So that includes anything from the engineering to the detailing, project management, production planning, fabrication, painting, loading, handling, shipping, and eventually onto site and putting it into place. So we like to think of ourselves as an end-to-end fabricator. In terms of education and careers here at Wolters, there's a whole wide range of people coming out of trade schools as well as universities, from engineering degrees to simply learning the tools at parents' shop and then coming here and applying for a summer job and going from there. In the shops, we have a lot of co-ops and apprenticeship programs in the fitting and welding roles, as well as in maintenance and millwrighting. So that's more on the fabrication on the shop side. And then in terms of continuing education and continuing your training, we have CWB certification, which is a welding test that needs to be done every 1 to 2 years. And that is something that we keep up with all of our fitters and welders. If anyone does need more training in terms of robotic training or more courses in engineering, then those are all available as well. In terms of the careers here at Wolters, there's a wide range of positions and careers that we do here, from the design assist engineering on that side to estimating and sales to IT that helps us run everything, along with the project managers, engineers, detailers, production coordinators, down into the plants with the plant managers, team leaders, fitters, welders, material handlers, painters, loaders, and truck drivers. And then once it gets to site, we use iron workers to erect our steel. So there's a wide range of careers available here at Wolters. So this here is our steel processing cell. This here is where the fabrication process really gets started. So you can see along here we've got 3 pieces of equipment and a 4th one on the other side that we'll cover in a minute. As the steel slides in and out of each machine using rollers and transfers, the steel gets processed along the way. First, the steel will go through a scriber, which adds identification marks and locations onto it. The second piece of equipment you see here is a drill. That drill is three-sided spindles. It's got spindles that are drill bits on 3 different sides. So we can drill all the faces of the structural steel that's rolling through it. After it comes through the drill, it moves over via transfers and comes through the bandsaw and cuts it to length. After it goes through the saw and it's cut to length, it goes over to our coper. The coper is a plasma machine that cuts web openings or copes, any kind of openings. It can do holes as well if the holes are big enough. But like I was saying, it uses plasma arc to cut the steel. So after the steel goes through the saw, it goes over via transfers through our coper. After it goes through this coper puts all the web openings, so large mechanical openings in it, using plasma arc. It's got a robotic arm inside of it, and it uses that to cut openings or cuts, chamfers, bevels, anything like that onto the steel. So after the steel beams come through this coper, they are ready for the fabrication process. Before we had this steel processing cell or this type of automation, the old way of laying out beams by string line, chalk, and soapstone with mag drills was very labor intensive. And since we've added all this, it's definitely sped up the process a lot more. Beam lines have come a long ways over the years. I think we bought the first beam line we had in the 70s, and they've continually gotten faster, more efficient, and allowed us to increase our capabilities. So now we're inside one of our fabrication facilities, and this fabrication facility has a high level of automation to it. This facility is about 2 years old now, and the beginning of this process, we start with a robotic assembler. As you can see below here, the main material that just went through that processing cell we spoke about earlier, now the holes are already in it, now we're ready for fabrication. So once the beam gets loaded into this equipment, it slides through a set of transfers, and we're ready to start the robotic assembly. You can see the robot right now is scanning the hardware. It's using a scanning hood with the laser. This is so that the robot knows exactly where each piece of hardware is. So that hardware is just placed on the table. As long as it's laying flat on that table, this 2D scanner will be able to see exactly what's there. Once the scanning is complete, then the assembler will know exactly what's on the table. And all of these beams were pre-programmed, and the robot will then use a magnet, which you'll see in just a minute, to place these pieces of hardware onto the beams. So now that the beam has entered into the fabrication cell, we have 2 smaller robots on these large blue towers, and they're using a laser sensor to know exactly where the beam is. So right now it's using a laser sensor to sense the end of the beam. Now that it knows where the start of the beam is, the second robot will sense where the plate is going, and it'll sense the height of the web. So the larger robot is using a magnet to pick up the plate, and now it'll put it into position, and then the smaller robot will come down and tack weld it into position. Once the plate is tack welded into position, the magnet will release and grab the next part. So the robot will use touch sensing as well, so that it knows that the plate is touching the web of that beam. So we always have a tight contact. So the program knows the theoretical location of that plate meeting the web, but it uses touch sensing to make sure it's actually touching. So the old way of building this beam would have been with a tape measure and soapstone, where you would grab the beam, lay out all your lines, find the plates, put them on, using a square and a tape measure to get them into the right position. After the steel comes out of the robotic assembler, it gets piled up here waiting to go to a welder. So all these assemblies will check for dimensional quality. We'll have our QC inspector come over, give it a check, not everything, but he will do a couple checks just to make sure that the robot is accurate. And from here, it goes into our welding cells. You can see these parts that were put on by the robot are only tack welded. So a tack weld is a very small weld, just large enough to hold the plate in place until it can get welded. The welder will use his iPad to pull up the drawing and determine what the correct weld size should be, and he will weld it up from there. So to move the material around the plant, we use cranes and this side loader. We prefer to use this side loader as it's much safer to pick pieces up. You don't have to worry about the cranes and the rigging and getting in the way of that kind of stuff, and making sure that the cranes and the chains have the capacity. So we use the combi lift to move the material in and out of all of the stations. We load the trailers in our loading docks right behind me here. Now, the interesting thing about these is when we designed the facility, we lowered the loading docks so you can walk right onto the trailers. This way here, the loaders do not need to climb up onto the trailers and then climb on top of that load. This greatly reduces any safety hazards associated with loading trailers. From here, the steel will either go straight to site and our iron workers will erect it from there, or it will go to one of our painting facilities to be blasted and painted with the finished coat.